Consider this. Every single day, your body is like a bustling, super busy city. And just like any city, it needs a top-notch security force to keep things running smoothly. This security force is your immune system. It's a complex and wonderful network of cells, tissues, and organs all working together around the clock. Their main job is to patrol your body, looking for invaders like nasty germs, viruses, and bacteria that could make you sick. When they spot one of these troublemakers, they spring into action, neutralizing the threat before it can cause any real harm. It's an amazing biological defense system, and it's working for you right now. Think about the last time you got a small cut on your finger. At first, it might have gotten a little red and swollen. That wasn't just an OE. That was your immune system rushing to the scene. Special cells were sent to fight off any germs that might have tried to sneak in through the broken skin. They cleaned up the area, prevented an infection, and then helped your body start the healing process. Your immune system is constantly doing this kind of heroic work, protecting you from countless threats you never even know about. It's your personal built-in team of superheroes defending you 24/7. But what if this powerful defense team got a little confused? What if, instead of just attacking outside invaders, it started to see your own healthy cells as the enemy? This is a really important question, because an immune system that can't tell the difference between friend and foe can cause a lot of problems. It's like having a security team that starts arresting innocent citizens. This mix-up is the root cause of a whole category of diseases. Understanding how the body prevents this from happening is one of the biggest puzzles in modern medicine. A puzzle that has now been brilliantly solved. This delicate balance, knowing when to attack and when to stand down, is called immune tolerance. It's the secret to keeping your powerful immune system in check, ensuring it only targets genuine threats. Without this control, the very system designed to protect you could turn against you, leading to chronic inflammation and damage to your own tissues. For decades, scientists have been trying to figure out exactly how the body maintains this crucial piece. Finding the off switch or the peacemakers within this system has been a holy grail for immunologists, promising a new era of treatments for many challenging diseases. Now, let's give a huge round of applause for science. This year, on October 7th, 2025, the Nobel Prize in Physiology or Medicine was awarded to 3 incredible scientists who solved that very puzzle. Let's meet our science heroes, Mary E. Brunkow and Fred Ramsdell from the United States, and Shimon Sakaguchi from Japan. These brilliant researchers have been honored for their groundbreaking discoveries about a special type of cell that helps our immune system keep the peace. Their work has fundamentally changed our understanding of how our bodies protect themselves not only from germs, but also from themselves. Their prize-winning work is all about a set of cells called regulatory T cells, or TREGs for short. Think of these TREGs as the highly trained security supervisors or the diplomatic peacekeepers of your immune system. While other immune cells are the soldiers on the front lines ready to fight, the regulatory T cells are there to make sure the soldiers don't go too far. They are the ones who step in and say, "Whoa, hold on, that's one of our own. Stand down." They enforce the rules and prevent the immune system from launching a misguided attack on the body's own healthy tissues. This discovery is a really big deal. Before the work of Brunkow, Ramsdell, and Sakaguchi, we didn't fully understand how this crucial self-control happened. It was a mystery. We knew the immune system was powerful, but how did it know when to stop? These scientists identified the specific cells responsible for this regulation and figured out the genetic key that makes them work. It's like they not only found the security guards, but also discovered the instruction manual that tells them how to do their job properly. This insight is revolutionary for medicine. Winning a Nobel Prize is the highest honor a scientist can receive. It recognizes discoveries that have brought the greatest benefit to humankind. In this case, the benefit is immense. By uncovering the role of regulatory T cells, these 3 laureates have opened up entirely new ways to think about and treat a wide range of debilitating diseases. Their decades of patient, careful, and brilliant research have given us the tools to potentially correct an immune system that has gone wrong, offering hope to millions of people around the world.
Science is awesome.
So, how did they figure all of this out? The story begins back in 1995 with Shimon Sakaguchi. He was studying mice in his lab in Japan and noticed something fascinating. He found that if he removed a very specific group of T cells from a mouse, the mouse would suddenly develop severe autoimmune diseases. Its immune system would start attacking its own body. But if he put those cells back in, the mouse would get better. This was the first major clue. Sakaguchi had discovered a new type of cell that was essential for preventing autoimmunity. He had found the peacekeepers. A few years later, across the Pacific, Mary E. Brunkow and Fred Ramsdell were tackling the problem from a different angle. They were studying a special strain of mice that was extremely prone to autoimmune diseases. They wanted to find the genetic reason why. After a lot of detective work, they pinpointed a mutation in a single gene. They named this gene FOXP3. They realized that when the FOXP3 gene was broken, the mice's immune systems went haywire. They also connected this to a rare but severe human disease called IPEX syndrome, showing that people with a faulty FOXP3 gene suffer from devastating autoimmunity. Then came the big aha moment that connected everything. In 2003, Shimon Sakaguchi put the pieces together. He proved that the FOXP3 gene, discovered by Brunkow and Ramsdell, was the master switch that controls the development and function of the regulatory T cells he had discovered years earlier. In other words, the FOXP3 gene is the instruction manual that creates the security guards. If the manual has a typo, a mutation, the guards can't be trained properly, and chaos ensues. This unifying discovery created a complete and elegant picture of how our bodies maintain peace within. This is a perfect example of how science works. It's not usually one person having a single flash of genius. Instead, it's a collaborative, step-by-step process where different scientists build on each other's work over many years. Sakaguchi found the cells. Brunkow and Ramsdell found the gene. Then Sakaguchi connected the gene to the cells. Each discovery was like finding a different piece of a giant jigsaw puzzle. When they put their pieces together, the full picture became clear, revealing a fundamental mechanism of life and giving us a new roadmap for fighting disease. So, why is this Nobel-winning discovery so exciting for all of us? Because it has paved the way for brand new treatments for some of the toughest diseases out there. Think about autoimmune conditions like rheumatoid arthritis, lupus, and multiple sclerosis. In these diseases, the immune system mistakenly attacks the joints, skin, or nerves. By understanding regulatory T cells, we can now develop therapies that boost the number or function of these peacekeeper cells, essentially teaching the immune system to calm down and stop attacking the body. This offers hope for cures, not just treatments that manage symptoms. The impact doesn't stop there. This knowledge is also revolutionizing cancer treatment and organ transplantation. In cancer, the problem is often the opposite of autoimmunity. The immune system isn't aggressive enough, and sometimes tumors are protected by too many regulatory T cells that tell the immune system to stand down. By finding ways to temporarily block these tregs near a tumor, we can unleash the full power of the immune system to attack and destroy cancer cells. For organ transplants, we can enhance tregs to prevent the body from rejecting a new kidney or heart, reducing the need for harsh drugs. The work of Brunkow, Ramsdell, and Sakaguchi is a powerful reminder of the value of basic science. These scientists weren't trying to cure a specific disease on day one. They were driven by curiosity. They wanted to understand a fundamental question: how does the immune system work? Their dedication to answering that basic question is what led to this incredible breakthrough that will now help countless people. It shows that by investing in scientific exploration, we lay the groundwork for the medical miracles of tomorrow. The journey from a mouse in a lab to a life-saving therapy is long, but it starts with fundamental discovery. As we celebrate this incredible achievement, we are filled with excitement for the future of medicine.
The discovery of regulatory T cells has given doctors and scientists
completely new tool to work with. New companies, like the one co-founded by Fred Ramsdell, are already developing therapies based on the cells. We are standing on the edge of a new frontier where we can fine-tune the immune system with incredible precision. Thanks to the persistence and brilliance of these Nobel laureates, we are one giant leap closer to a world of better health and more hope for everyone. Consider the state of the world. It's changing. Science has found a change for the better.